Okay, we're going to do a quick review of the law of exponents, the rules of powers for our SAT prep. We will be going over this when we do the logarithms in February. But for those of y'all that are taking your SAT in December, this would be a good review. Okay, so here are some basic properties that you need to know. You have your product property, your quotient property, your power property, and then your inverse property and your identity here, and then there's some more. So I think most of you already know these from Algebra 1 and Algebra 2, and we're going to go ahead and do some examples based on these properties. Okay, and here's two more properties with the changing from radical to rational expressions. Basically, on exponents, when they're talking about exponents and they're saying rewrite the equations using the same base on both sides, the base is this number here. So if we go back, the base is right here when they're saying let A, if A and B belong to the reals. They're talking about the base. This is your base, and they're letting your M and N, which is your powers, belong to the positive integers, where and then A can't be 0 and B can't be 0. And they're basically saying the base can't be 0. So it's all real numbers but 0. Okay. So the one thing I wanted to go over quickly is I'm going to have a base of, say, 3 and my power of 0. And we know from our identity that this equals 1. Okay? And everyone asks me, how do you know this? And I give a very simple example. If I have 3 cubed over 3 cubed, so my bases are the same. If you wanted to, we could call this 27 over 27. We know that this equals what? 1. Well, if I use my quotient property, which is this one right here, I'm going to use my quotient property and do it this way. I'm going to let this be my M and this be my N. So I have 3 to the M minus N, which is 3. I should have changed it to square some, but to the 3 minus 3, that gives you 3 to the 0, which equals 1. We already know it equals 1 because we did an example. Okay, so we're going to go ahead and start doing some examples. On your SAT, you won't be doing the logarithms on both sides. However, in class we will in February. Okay, so let's start. Before we solve them, we always must check the solutions and disregard solutions that are not permissible. For example, we have, for number 1, we have 3 to the x plus 1 equals 81. And we're supposed to solve that. Okay, from what we're going to do from our previous page is rewrite the equation right here. We're going to rewrite it using the same base on both sides. So we should know that 81 can be written as 3 to the 4th. So 3 to the x plus 1 equals 3 to the 4th. Since my bases here, this is my base, are the same, I can simply take my powers and set them to equal each other. So I have x plus 1 equals 4, and just by looking we know that x equals 3. Now, we're supposed to check, and if I plug this in, I'm going to put 3, my x is 3, to the 3 plus 1 equals 3 to the 4th, which does indeed equal 81. Okay? So let's try another one. Let's try 3 to the x plus 1 equals 9 to 2x minus 1. My bases clearly are not the same. I'm going to make my bases the same. So if 3 to the x, and always go down. Since that's 9, we're going to go down to 3. So that's 3 squared. And whatever is here, we're going to multiply that by 2. So 2x minus 1. So we get 3 to the x plus 1 equals 3. I'm going to distribute to the 4x minus 2. Since my bases are the same, I really don't need those anymore. And I'm just going to set these two equations here equal to each other. I have x plus 1 equal 4x minus 2. I'm going to subtract x from both sides and add 2 to both sides. So I get 3 equals 3x. So x equals 1. And indeed, if I go through here and plug in 1, I'm going to get 3 to the 1 plus 1 equals 9 to the 2 times 1 is 2 minus 1. So 3 squared equals 9 to the first power, and it checks. Or 9 equals 9. Okay? Now, here's where we're going to get into the next step. We're going to solve and we're going to use substitution. So, we're going to try 4x minus 3 times 2 to the x minus 4 equals 0. Well, the first thing I'm going to do is I'm going to let a equal 2 to the x. And in this case, what I'm going to do is change this 4 to 2 squared. So that would be 2 to the 2x. I'll rewrite this real quick. So everywhere there's an x, I'm going to put a. In this case, I can also rewrite this as 2 to the x squared based on my power property. My power property says I can multiply this, and when I multiply these two numbers, I get back to here. So if I let a equal 2 to the x, I'm going to get a squared minus 3a minus 4 equals 0. I'm going to factor, and I'll get a minus 4 times a plus 1 equals 0. So a equals 4, and a equals negative 1. Now, be careful. You don't want to stop here. Because remember, what is a equal? 2 to the x. So I'm going to substitute back. 2 to the x equals 4. And we have 2 to the x equals negative 1. This is not permissible here. So this one right here doesn't work. There's no exponent where this is true. But in this case, I have x equals 2. Okay, and if you plug the 2 back in to your x here, it should work. Okay, let's do a few more. Go a little faster. We have 3 to the 4x equals 81. And we did one similar to this. So I'm just going to change this to 3 to the 4th. So we have 3 to the 4x equals 3 to the 4th. And clearly x has to be 1. Okay? Here's another symbol for you. It's 3 dots in a triangle. This means therefore. So instead of writing therefore all the time, we'll do this. Alright? Let's try another problem. Let's try one with a fraction, a rational. because it said the bases could be all real numbers. That means we can have radicals and fractions or rationals. Now, I want to have the same base. So, I can either change this to 1/9, or I can change this to 3. I need to have these the same, and they're not. Preferably, I'm going to change this one. I know that 1/9 equals 3 to the negative 2. Because 3 to the negative 2 equals 1 over 3 squared. Okay? And that's what this is here. This 1 over 9 is, this equals 1 over 9. Alright? You can try changing this one also. You could change that as well. So, we have 3 to the 4x plus 1 equals 3 to the negative 2 times x minus 1. Now, since my bases are the same, kind of don't need to look at those anymore. And then I have 4x plus 1 equals negative 2x plus 2. All I did was distribute here. I'm going to combine like terms. I'm going to add 2x to both sides and get 6x. I'm going to subtract 1 from both sides, and I get 0. So if I subtract, oh, this should have been plus 2. Alright, so when I subtract 1, I get 1. So therefore, x equals 1/6. And again, you could plug that in and check that out. Okay, here's one with a different kind of radical. We have x to the 2/3 equals 16. Now in this case, all I'm going to do is multiply or power both sides by 3 over 2. Now, and what will happen here, this equals 1, because this would be x to the 6 over 6. And here we're going to get 16 to the 3/2. So x equals 16 to the 3/2. Remember on our properties here, I'm going to go back. Wow, done a lot of work. What we're going to use is this right in here. Okay? This is written in rational form, and we're going to change it to radical form. Not that we have to, but only because that's what we're used to seeing. So the way I'm going to write this is my root. So when I have the 3/2 here, this is my root, and this is my power. So I'm just going to change this to the square root, because that's the 2 part, of 16 cubed. Now, it doesn't matter which you do first, if you power it up or you take the square root or the cubed root, but it's always better to do the root first, because you can work with smaller numbers. So the square root of 16 is 4. Then you cube that and you get 64. Therefore, x equals 64. Okay? Let's do something with the decimal. We have 0.25 to the x equals 4. Now, personally, you can do this. I think a lot of you already know what's going to happen here. I already know this is 1/4 to the x. And this is how I'm going to write it. Equals 4 to the, I'm going to go ahead and put the first power. Now, this is like that other one we did. We can change this one, or we can change this one. But bottom line, they have to be the same. In this case, I'm going to go ahead and do something different. And I'm going to change this one, just to be different. And I'm going to write this as 1 over 4 No, I don't want to change that one. I just don't like to. I always like to make them this one. So I'm going to change this one as 4 to the negative 1. Because 4 to the negative 1 equals 1 over 4 to the first power. Equals, so that's negative 1 times x. Equals 4 to the first power. So we have negative x equals 1. There, and if you negate everything, you get x equals negative 1. Therefore. Okay? Now, here's a couple trickier ones. They're not tricky, but this is the kind of thing the SAT will do to you. We have, for example, they're going to say if 4x equals 7, then what does 4 to the negative 2x equal? Alright? So the main thing I want to do is I want to change this part in here to something with the 4x. So if I write this as 4x and I want these two to be equivalent, what would I put here to make these two equal each other? And that would be negative 2. When you use your power property, this would be 4 to the negative 2x because you just multiply these two right here. So the reason I'm doing that is because I know 4 to the x equals 7. So all I have to do now is put 7, use substitution, to the negative 2, and I know that is 1 over 7 squared, which is 1 over 49. And there you go. Let's try another one. If 2 to the x equals 3, then what is 4 to the negative x equal? So bottom line is, I want this inside to be 2x because I want to substitute this eventually with 3. So what would I put here to make this look like this? And that would be negative 2x. Because if you work that out, that would give you 2, not negative 2x, just negative 2, sorry. That would be negative 2. Because that would give you 2 to the negative 2x. Or you could square that and that would be 4 to the negative x. Okay, so I would write 3 to the negative 2, which equals 1/9. 2 more we'll do quickly. If 3 to the negative x equals 2, then what is 3 to the 2x equal? So again, I want this inside here to be 3 to the negative x. Because if I can do that, I know I can get a 2 here. Because that's what this equals here. So, what would I put here to make this look like that? And that would be negative 2. I'm going to just check real quick. Negative times a negative is positive, so you have 3 to the 2x. Now, since I know that that's the case, all I'm going to do is substitute for my 2 here and put the negative 2. That gives you 1 over 2 squared, which equals 1/4. The last one I'll let you try. If you have 5 to the negative x equals 3, then what does 5 to the 3x equal? And you try.